5G introduced local private networks concept. I'm going to talk to you today about how should we move forward with that to have more generic local 6G connectivity solutions. Hello everybody, my name is Matti Latva-aho. I'm Director for 6G Flagship, University of Oulu. Some facts related to our flagship. It's an 8-year program. We started already beginning of 2018 and will run towards the end of 26. We were pretty active in the very beginning in starting to form jointly with a group of global experts 6G visions. We are 13 6G white papers that have been successfully received by research community and already downloaded over 1 million times. In our flagship, we have a pretty broad research agenda. We are covering lots of different issues from technology areas, of course, relevant technology areas, to different sustainability targets, reflecting to regulation and future business models. I don't think this broad research program is that typical in any relevant similar research program currently. Our 6G flagship vision papers are also pointed out in this around this research agenda as these smaller texts written in black, and we addressed all these relevant different areas separately in the white paper. The flagship, we are focusing also in the second phase to 4 strategic research areas: wireless connectivity, divided circuit technologies, distributed computing, and services and applications. And with those, with this setting, we aim at developing sufficient technology enablers towards 6G. We also aim at building national 6G test network. We try to build also and deepen our understanding in 6G vertical applications, which we have chosen to be the following 4 ones: health, industry, vehicular, and energy sectors. Now let's look at where we are today and what 5G has promised in the early phases of 5G development. This is an European Union 5G research vision mapping what 5G should be building on top of what 4G LTE was able to provide. Around the time 2013, this was presented, and looking at these different aspects, amazingly fast, always best connected, no perceived delay, etc., energy efficiency, flexible networking, security. All these targets are definitely valid even today when we talk about 6G targets. And it's fair to say that we haven't already met all the goals set for 5G. Of course, the numerology needs to be updated to what we were targeting at in 2013 or so, but the generic goals are still relevant. In 2015, IMT 2020 requirements were set to target at 3 different use cases: extreme mobile broadband, massive machine-type communications, and critical machine communications termed URLLC. These, of course, need to be now looked at very critically. Where are we today when 5G is being deployed to the markets? It actually turns out that we are mainly talking about mobile broadband at these early phases of 5G introduction, and this massive machine-type communications, critical machine communications, has not shown up yet as everybody was hoping for, and as everybody was hoping that to be the major force to transfer current industrial production to a totally different level that it has been for a long time. Nevertheless, I think everybody is still waiting for what is the killer application for the future? In the beginning of mobile phones era, it was voice-oriented applications with maybe some text messaging. Then LTE really kicked forward mobile broadband. And for 5G and 6G era, everybody is talking about IoT and expansion of application space to lots of different directions. But we don't have clearly identifiable killer app that might really be driving the change dramatically. So today, at early phases, we are definitely waiting for a killer app, so to say, to show up. But what could be a killer app? From what direction could it come from? Is it really related to AI and machine learning enabled totally new types of applications, or is it coming from different verticals? Different verticals have different needs. We have a huge number of different highly important areas that society would need for enabling full-scale digitalization of societies. And this is really a big potential that most likely will drive also 6G development, although it didn't happen yet in 5G. Actually, one of the big challenges is that different verticals have quite different needs in terms of key technical parameters. Here we have just described some typical vertical areas and some typical KPIs, technical KPIs related to it, system requirements, and the variation of these different parameters, it's really huge. It's amazingly huge, and one can claim that there is definitely no one solution fitting all problems anymore. That time probably is over. So we must allow a certain level of customization of RAN concepts for being efficient for different types of verticals. Well, when we look back 4 or 5 years from now, research community, industry, they have presented different technical targets already now for 6G development. ITUR will define, of course, later on IMT 2030 requirements, but this probably gives you an idea where we are now. The requirements are really extreme for all possible levels, and it's really difficult to find one solution which would satisfy all these different needs. Well, when we look at the future, I think one of the key things to understand is that regulation policies dictate how much innovation we can allow in future developments. For example, if you look at spectrum regulation, which is only one part of the regulation, important one for us, of course, there is huge potential, especially at higher spectrum bands, for deploying totally different spectrum ownership, spectrum sharing models that would allow quite different way of owning, building, running, operating future wireless networks. Currently, MNOs own huge amount of big majority of the spectrum. Vertical players, very little. Maybe if this future digital society would really happen one day, maybe verticals should have also access rights to spectrum, which is probably possible at higher spectrum bands in the future. And also it makes much more sense since higher spectrum parts, the signal propagation conditions are such that the communication ranges are drastically shorter, no matter what, compared to what we have at lower spectrum bands. So the owner of the space probably should have a role, whatever the space we are talking about, whatever vertical we are talking about, what type of application and services we are offering, they have incentive in building, investing, operating, maintaining the network, and also creating the relevant context related services that is needed in different application spaces. Very long time ago, already 2015-16, we presented this idea of micro operator concept. You can see it as a local operator, which is much broader concept compared to current private 5G network concept, which is mainly non-public mobile network extension for local coverage. I think our concept is broader. It also allows and suggests roaming, national roaming, and can offer public access to the network if so desired. So we see that this is one important factor that we should try to introduce in 6G in order to allow new entrants to offer services, to provide new investments, to build networks and services for the future needs of different sorts. Of course, broadband connectivity is what is driving research to big extent, and there are many different challenges that we have identified for our research. And I would say that to a large extent, the whole research community is looking at these same areas, and there are lots of work to be done before we have a complete solution for 6G system concept. Lots of the challenges are related to practical implementation of these novel ideas and how can we implement those cost and energy efficiently. Still a lot of work to be done. But we all don't know how we can increase capacity the most straightforward manner. We need more spectrum. We have to go to higher spectrum bands. We also need to allow densification to the extent that we have enough capacity per area. So this might result in rather cost-efficient solution, especially as there might be lots of new players coming and implementing their local clusters for implementing different types of services. Improving spectrum efficiency requires novel transmission schemes development, and as we know, they are quite often very complex, can go a little bit high in the cost efficiency side, and probably not as efficient ways, but still definitely needed as these two other components in improving capacity. So to start to summarize a little bit, what are the key drivers for 6G development at research phase and later on when we try to make it reality? First of all, digital inclusion is important thing, and we want to make sure that around the world we have digital services for future citizens of different societies. We must allow and must foster birth of new ecosystems, and we must try to find disruptive new business models. Future digital societies need to allow and push even new verticals to create their own ecosystems, and we need also regulatory changes to make that happen. Global collaboration and standardization remains as a very important factor also in the future. We must understand that if we want to change spectrum regulation principles, the cycle of changes is extremely long, and we shouldn't probably expect too sudden changes in that respect. Then there are, from technology perspectives, there are lots of different important